So in this video we're going to do an improper integral that winds up causing us to need to evaluate a limit for the arctan function. So here's the integral we're interested in. This is the integral from 0 to infinity of 1 over x squared plus 1. So I'm going to rewrite that integral. I have the integral from 0 to infinity of 1 over x squared plus 1 dx, and because we have infinity as one of the limits of integration, we're going to switch this over to taking a limit. So we're going to take the limit as a goes to infinity of the integral from 0 to a. So we replace infinity with a, and then we take the limit as a becomes infinitely large, and this is going to be 1 over x squared plus 1 dx. And there are options for integrating this. So this is one that we already developed in Calc 1. This is actually the derivative of the arctan function. So when we integrate 1 over x squared plus 1, we get the arctan function. So one possibility is we remember this integral. Possibility number 2 is we look it up in a table of integrals, which was the subject of the previous homework assignment. Or possibility 3 would be to look at this and say, hey, I think I can attack this using a trigonometric substitution. And the method of trigonometric substitution is exactly the method that can be applied to this to come up with the integral that is in the table of integrals. So I'm just going to go ahead and integrate this. We outlined 3 possible ways for dealing with it. I'm going to keep my limit notation because I haven't taken a limit yet. So we're taking the limit as a goes to infinity. This is going to be the arctangent of x evaluated from 0 to a. And then we can go ahead and plug in our limits of integration. So we're going to get the limit as a goes to infinity of the arc whose tangent is a minus the arc whose tangent is 0. And if this feels awkward to you because it's the arctangent function, you just need to review what you know about the tangent function from your work that you did in trigonometry. So let's think about the tangent function. The tangent function had vertical asymptotes that repeated themselves infinitely many times. So I'll do three periods. It went like this, it came up through the origin like this, it came up through the origin like this. And when we wanted to define the arctangent function, the inverse tangent function, what we realized was that the tangent function didn't pass a horizontal line test, so it didn't have an inverse. So what we needed to do was restrict the domain so that we were only looking at the tangent function between the first 2 asymptotes, because between the first 2 asymptotes the tangent function passes the horizontal line test and therefore has an inverse function. So what we did with the tangent function is we said we're going to throw away all of the tangent function except the parts that live between the vertical asymptote at negative pi over 2 and the vertical asymptote at positive pi over 2. And between those 2 asymptotes, it sweeps up through the origin and then up along its vertical asymptote towards infinity. I need to take art classes. Okay, so for the tangent function, what we did is we said, hey, we're going to restrict the domain, the input values. We're going to restrict the domain or the inputs to run on the open interval from negative infinity to, from negative pi over 2. My brain's getting ahead of my hands. Negative pi over 2 to pi over 2. We're going to let the inputs run between the first 2 vertical asymptotes. And if we do that, the range of the function, the outputs, we can see that they're going to run from negative infinity, the tangent function goes to negative infinity, all the way to, hey, the tangent function's giving outputs going towards positive infinity. So what we want to remember with the arctan function, because it's the inverse function of the tangent function, the arctangent function is the inverse, the range of the tangent becomes the domain of the arctangent. So the domain of the arctangent is going to run from negative infinity to infinity, and its range is going to run from negative pi over 2 to pi over 2, and the arctan would be the reflection of this graph in the line y equals x. So when you reflect it, you're going to get something that goes like this. It's going to come through the origin and zip up, and it's going to have a horizontal, the vertical asymptote becomes a horizontal asymptote at pi over 2. So the key here to recognize is that as a goes to infinity, the output for the arctangent function is going to go to pi over 2 as the arctangent approaches this horizontal asymptote at pi over 2. So this limit right here, as a goes to infinity of the arctangent of a, is going to say, hey, as it goes to infinity, the outputs run and get closer to pi over 2, and the arctangent of 0, the x is, let's see, this is a tangent function, goes through 0, 0. So the arctangent function is also going through 0, 0. So the arctan of 0 is 0, and we get just pi over 2 as our limit.